Hello everyone, welcome back to the channel. And in today's video we are going to build a smart AI powered Shop Assistant, which is a chatbot that lets users ask questions about the store's product catalog. Okay, and this app combines Streamlit for the front end, FastAPI for the back end, and Gemini AI for our generating our responses, and Pinecone for our vector search, and all this backed by a MySQL product database. Alright, so we'll first see a demo of the app, and then I'll walk you through how it all works, including the modular structure, data flow, and all the AI tool involved. Alright, so let's get started. So first let us see the demo of the application. Okay, you can see our shop product catalog, and here we can filter our product using this filter with respect to our brand, with respect to our gender, and sort by price, and we have low to high and we have high to low. Okay, and these are all the products that we have in our database. Okay, so first let us see some filtering first. So let's say products with brand of Adidas, right? So you could see all the products with brand Adidas will come over here. Then products with men, you see all the men product. And now sort by price, high to low. So as per Adidas men, we'll see high to low from 16,999 to, you can see, 7,999, the lowest. Okay, now let's ask some questions. So first let's say, what's the price of this Superstar Pro? Okay, so what is the price of Superstar Pro 5, which is a Nike shoe? I'll send. Let's see. Okay, so hi there, the Adidas Superstar Pro 5 in red is priced as 16,999. So where's gone Superstar Pro 5, right? Where is this? I said Nike, right? So Nike Superstar Pro 5. Okay, so I actually write the wrong prompt because Superstar Pro is from Adidas and I wrote Nike. So if I come into Adidas, you could see Superstar Pro 5 cost around 16,999. Okay, now let's say see some other brand. Let's say Puma, right? Let's say, okay, we don't have any brand shoes of Puma, so let's check. Okay, we have a unisex shoes, not men's shoes. So I'll copy this one, and here, what is the price of this? Okay, the price is 6,799. Okay, let's see. So 6,799. Okay, so this is how it will work, and you can ask how many questions if you want. Okay, so we'll build this application today with FastAPI backend with bit of modular backend structure. All right, and if you want any kind of feature updation for this application, comment your thoughts. Okay, and I'll try to add them in our next videos. Okay, so now let's see the workflow of the application, right? So the application will start from taking the user's query input. So a user enters a query in the chat UI, then this query is sent to the backend of the API. Okay, and then this backend fetches product data from our MySQL database, which then our embedding model, which is our Gemini embedding, like Google's embedding model, will generate a vector embeddings for all those products, and then we will store them into our Pinecone vector database. Then as per the query given by the user, will retrieve the relevant chunk or the relevant product chunks from our Pinecone vector database. Then our Gemini API, by having all this context of our embedding vector store for our product and our user query, it will generate a conversational response using all those context, and then this response is displayed in the Streamlit UI. Okay, so this is how this whole application will work. And now if I have to tell you about the application's core modules or the application architecture, it will consist of around 9 modules. So the first, of course, our Streamlit UI initialization. So the Streamlit application start displaying the chat interface and the product cards. Second, our user interaction. The user interacts with the chat interface or filter products. Okay, so as you have seen in the demo that we have 3 filtering options, right? Then also we have FastAPI route handling system. Then we have Gemini chain execution to generate our responses. Then we have Pinecone vector store interaction. Then of course data retrieval from our MySQL Workbench database. Then Gemini response generation. Then our Streamlit display after getting the response from our Gemini. Then data ingestion process, which is a extremely important module where we'll upload our data from our CSV file to our MySQL database. Okay, and we'll complete each and every module step by step, and at the last and at the end we'll create the whole application together. All right, so now let's get started. So first let's talk about the prerequisites, right? So we need a data set that will be our shop's product catalog. So I'll be giving you this Kaggle's dataset link. Okay, and come in here and you could see the dataset. We have product ID, product name, product brand, gender, price. Simply download the dataset from here. Okay, then for our vector database we'll be using Pinecone database. So sign into your Pinecone account and get your index. Okay, and get your API keys. Okay, then we'll be using Gemini API key. So log into Google AI Studio and use a Google project to get your Gemini API key. Okay, then we'll be needing one MySQL database. So I'll suggest you download MySQL Workbench from here. You just simply write MySQL Workbench download in this first link. Come over here and download the MySQL Workbench. Okay, and for our Python package manager we'll be using UV, which is extremely fast Python package and project manager. Okay, so yeah, that's being said, now let's set up our environment and install our dependencies. So now that we are in my IDE, now the first thing I need to do, get my terminal first, and over here I'll initialize an UV project, right? So UV init dot, because I'll create the project under this directory. So UV init dot, enter. You could see we have initialized a project as Shop Assistant 2.0 in this. Okay, now in this py project.toml, here we need to add those dependencies, right? So what we'll add, we'll simply add UV add first, like our first API, python.env. okay, and UV core. As of now I am adding this. Okay, and you could also see that it has initialized a virtual environment for me, right? Now let us activate that. So .venv slash scripts slash, what's the activates case? It was normal small case, so activate, right? So I'll come under my main.py and let's see in the TOML. You could see we have our fast API python.env UV gone, my Python version is 3.11. Okay. Now in my main.py, now let us try out. Now let us test our FastAPI point, because fast will be creating our whole backend, and at last we'll be adding those backend into our Streamlit UI. Okay. So first from FastAPI, I need to import FastAPI. Okay. Now need to initialize a FastAPI server. So app FastAPI, just provide the title with Shop Assistant 2.0. Okay, that's it. Now we need to define a get method, right? So app dot get, we'll use the slash. Now under here use an async def a root function. Here we'll simply return a message. Okay, so I'll just use the tab function to click on this suggested message. Okay, so we have this, our FastAPI server is initialized over here. We got our get method with this slash root, then our def main print hello shop assistant. Okay, now we need to run this. So to run that, we'll use uv corn main with app slash reload dash reload. Okay, and you could see my FastAPI backend is running at 8000 port. Now I'll simply copy this. I'll copy this code and I'll come to my Postman. And it's always better to, test your FastAPI always. So I'll create a blank collection. Here I'll name it as Shop Assistant 2.0. Enter. And you can easily download Postman desktop. Okay, and here you need to click on this plus sign to create a new blank collection, and after having your blank collection, in this three dot, click on that and click on this add request. Alright, you could see we have a new request. First I'll paste my port over here and I'll use this slash, because this is the method and this is the endpoint that will give me this, that return of welcome to Shop Assistant, right? So alright, I'll just click on this send, and here we go. You see, welcome to Shop Assistant 2.0. Okay, now let us test 01. Okay, I'll save it. Alright, so our FastAPI backend is done. Now the next module we need to create is our data insertion module, where we'll upload our CSV data to our MySQL Workbench dataset or our MySQL Workbench database. Okay, in our next step we need to upload our CSV data, this dataset, this CSV data to our MySQL Workbench database, right? So first we need to install a couple of dependencies so that we can do that by just simply run a script rather than using those SQL command, right? So I'll close my FastAPI backend, and here I'll add uv. I'll just get out of my, I'll just create a new terminal over here. Okay, here write uv add MySQL connector Python. Okay, and we need to add our pandas. Okay, enter, and you could see in our TOML we got our MySQL connector Python and we got our pandas over here, right? Okay, now second thing we need to do, we need to create a .env file, .env, where we need to get our MySQL Workbench password, db password, right? and simply paste your password over here. So my password is all right. Okay, so now let's see our CSV file first. So here you could see we have product name, product brand, we have gender, we have price, we got description, we got primary color, right? So we got total 3 and 3 6 and total 7 column. So coming to our MySQL workbench, now we need to first, I'll show you how to create our own schema first. So right click on this blank space, click on this create schema, and name your schema as completely small letter. Okay, so Shop Assistant 2. Okay, I click on this apply, finish. You can see we got this Shop Assistant 2 over here. Now here, as you could see, my cursor is on this only div. Now I need to change that to my Shop Assistant 2. So for that I'll use this use Shop Assistant 2. Okay, I'll run, and to run an individual line you need to click on this button which says execute the statement under the keyword cursor. So I click on this, you could see now my cursor on this Shop Assistant 2. But now you could see my I don't have any table right now. So I need to create a table. So to create a table I'll simply use this command. So you could see create table products. So my table name would be products, and we have product ID as my primary key. As we need to, as for each and every table we should always have a primary key column that will help us to identify the any particular row uniquely. Okay, so our product ID is our primary key. So product ID integer primary key, product name with the varchar of 255, product brand again varchar of 255, gender varchar 50, price varchar 50, description would be in my text format, and primary color again varchar 50. Okay, I'll simply run this again and I'll refresh this schema. You could see I have a table. Now to get this, I'll click on this table, I'll right click, I'll click on this select rows. You could see I have products. As of now I have null in my every column. Okay, now we need to write the script so that we can upload those CSV file from our, like, by just simply running the script, right? So for that I'll create a new folder as data. Here I'll create a new file as data insertion.py. okay, now first we need to import our libraries. So we need to import MySQL connector. So MySQL connector, then we need to import pandas as PD to take care of our CSV data frame, and our OS to get our API key to see that do we even have what API key or not, right? And from .env we need, and this will help us to get our .env variable, right? Now call our load.env function to load our environment variable. Now we need to read CSV file. Okay, and we'll do that using simply CSV file. We'll use first our path. So we have this path as shop product catalog.csv. so here in my CSV file I need to provide my dataset path. So shop product catalog.csv. now in data variable I'll simply use my pd dot read CSV, and I'll simply provide my CSV file over here. Okay, done. Now in this data right now I have my CSV file. Okay, now I need to connect this script to my MySQL. So connect to MySQL, right? And how we'll do that? We'll initialize a variable as db connect. Here I'll call my MySQL dot connector. Then I'll use the function connect. Here I need to give some parameters to tell my script that connect my this particular database, this particular table, right? So first we need to provide the host, and host will be localhost, of course. Then for our user it will be root, and whenever you'll be downloading your MySQL Workbench, it will ask you to give a username and a password, and my default username is root and my password is that I have stored in my .env file. Okay, so in my password I'll use os dot get env, and I'll simply use my db password. Okay, and after that my database name, so my database name which would be Shop Assistant 2, right? All right, now this function will help me to connect, but to connect we need cursor, and cursor helps to execute each and every like individual operation in database, right? So I'll use a cursor. Here I'll use my db connection, my db connect. Okay, and then I'll use my cursor over here with my cursor function. Okay, now as I have connected my this particular Python script to my database, now I need to see how can I upload my each and every row data to my that particular table, right? So for that, upload data to the table. Okay, so here what we'll do, we'll run a loop. So for index and row in my data dot iteration of every rows. Okay, then I need to use an empty SQL command like this. This will be our query for each and to upload each and every row. After that, again to execute this query we'll be needing our cursor. So cursor dot execute, provide my SQL query, and in the tuple I need to provide the row. Okay, and after the for loop at the end I need to provide my db connect dot commit, and commit helps us to kind of save each and every operation in our database. Okay, and after that a basic rules to close your cursor. So cursor dot close, and then again close the db connect. So db connect close. All right, done. Now we'll come over here and I'll run this file. So Python sorry, we have under this data, right? So Python, let's get under data first. Data, now here Python data insertion.py, right? Just let's run this and let's wait a bit. Alright, so here is some error. We got some error. It's saying no such file or directory as shop product catalog.csv. Right, I need to get this CSV under this data, right? So I'll just drag and drop up into this. Alright, so I have moved my CSV file to this data folder. Okay, now I'll run this file again. Again, I'm having an error. iter rows, there is some issue. Of course, it will be iter rows again. You save it. I'll run this file again. You see, not all parameters were used in the SQL statement. Insert into products. So the problem is insert into products sender. Sender should be so okay. Price sender price description. All right. I'll run this again. Python data insertion. So yeah, I need to add one more string. So total 7. Now if I run this, alright, you can see now it's worked. I'll refresh it again. I'll come into my product. I'll run this command. Alright, you could see we have uploaded all the data in my this particular data set, particular database table. Okay, so now our next step would be our Pinecone sync file, where we'll fetch all the row from this table and we'll embed them and we'll upsert them into our Pinecone index. Okay, all right, so now our work would be to upload this data to our Pinecone vector database as an embed vector format, right? So we have to create another index over here, and we'll create that from our script, not manually. So first we need to install a couple of dependencies again. In my TOML, I'll be adding a couple of dependencies. So I need to add UV, add LangChain, Google, GenAI, and we need to add Pinecone client and our TQDM. And the reason I'm using TQDM, because while we'll be showing that progress of uploading our vectors, TQDM will be giving us those good progress bar to understand how much we have done or not. Okay, so we are adding LangChain, Google GenAI, Pinecone client, TQDM. Enter. We got Pinecone client .env, everything is there. All right, now let's wait for the adding. All right, done. Okay, now here I'll create a new folder as, not here, in the root, as embedding. Okay, and under this embedding I'll create a file as sync pinecone.py, not pinecone, it will be pinecone.py. Okay, all right, so first we need to import couple of libraries. So import our OS, then import time, and we'll use time to give us to kind of relax our application for a bit, so that our Pinecone first create the index and then we'll upsert our vectors. Okay, then our MySQL dot connector, and we need from LangChain Google GenAI, we need to import our Google Generative AI embeddings, and we'll be using embedding 001 model. Okay, from .env we need to import load.env, and of course the main library from Pinecone. We need to import the Pinecone and our serverless spec. All right, and the reason we are using serverless spec because we'll be using the free tier of Pinecone. So here we need to give the parameter of which region and which cloud we are using. Okay, so serverless spec, then from tqdm dot auto I need to import tqdm, and finally import pandas as pd. Okay, all right, now again load our .env file. Now what do we need, right, in our environment variable? Here we need to add our Pinecone index. So Pinecone API key, add your API key over here, and we'll also need Google API key. Okay, so paste your API key over here. Okay, now in this data inserts, now in the sync Pinecone, after load.env we need to configure our Pinecone. So Pinecone configuration, right? How we'll do that? Simply API key. Here first retrieve the API key. So os dot get env Pinecone API key. Okay, then to initialize the Pinecone index pc, call my Pinecone. Here I'll simply pass my API key, which is my API key. Okay, now to initialize the serverless index, so spec, here I'll call my serverless spec, and here I need to provide couple of parameters as cloud, which is AWS, and region, which is indeed US East 1. All right, now we need to give an index name. Like as you could see in this my Pinecone index, we have index name for everyone. We have role comparison index, shop product catalog, and product catalog index, right? So we need to give an unique index. So index, let's say Shop Assistant. All right, we have get our index. Now as I've said earlier that every index in my Pinecone index should be unique, so I need to check that if this index is already exist or not. So for that I need to retrieve all the indexes from my Pinecone. So my existing indexes, here I'll simply use a for loop to retrieve them. So for index info, for index info in my pc dot list indexes. Okay, so for index info in my pc dot indexes, I simply need to get index info, the name. So I need to retrieve the name of all the indexes. Okay, so after this line all my Pinecone indexes will be stored in this existing indexes variable. Just change the name from, all right. Okay, now as I said, we need to check if index already exists, right? So if my index name not in my existing indexes, what I'll do, I'll simply use this pc dot create index. This is not index name, this would be index. So if index not in existing index, I'll simply use this create index function, and I'll provide my index name. I'll provide the dimension of 768, and I'll provide the matrix of either you can provide you can use either cosine or dot product. Here I won't be using cosine, I'll be using dot product. Okay, and then for SPC I'll be provide my serverless variable. Okay, now the reason comes why my dimension is 768. As I have said earlier, we'll be using Google's embedding 001 model, and that particular embedding model returns a vector embedding with a dimension of 768. And the reason we are using dot product, because the dot product is one of the way we can multiply multiple metrics to get some information from them, right? So that's why in the matrix we are using dot product, and we are providing our spec where we are providing our region AWS and US East 2, which is US East 1, which is the free tier option. Okay, so after creating index, we just can't upload our data, because creating an index might take some time. So we need to give some initialization, like some relaxation time to our index, right? So for that I'll run a while loop. So while not pc dot describe to get the status of my index. So describe index, let's provide my index over here, and I'll use the status ready print, waiting for the index to be ready, then time sleep 5. So here what I've done, I'll first check that if my index, here I'm checking that my this index of, sorry, it will be SOP, my index of Shop Assistant, if this Shop Assistant index is ready. So I can't take it like that, I have to take it by this one quotation third bracket. So first I'm retrieving the status of my this particular index, and if it is not ready, then I'll be giving it some 5 seconds of time to make it ready. Okay, that's simple. All right, so after that we need to connect to the index, right? So here in my index, what I'll do, indexes, what I'll do, pc dot index, and I'll simply provide my index over here. Okay, and then again a relaxation time of time sleep of, let's say, 1 second over here. It will be pc. Okay, so now after that I need to connect to my MySQL again. So connect to MySQL, and I'll just simply copy that from here. I'll copy this, I'll paste it over here. Okay, now after that we need to get our Google API key. So Google API key, and I'll add them. So os dot environ, here I'll use my Google API key, would be my os.getEnv Google API key. Okay, and then my embed data, so my embed, let's say, model, here my model, I'll simply call my Google Generative AI embeddings, and here I need to pass that which model I'm using. So in the model I'll pass the model name, so model slash embedding hyphen 001. Okay, and this is the model that I'll be using, and this model returns us the vector with the dimension of 768. Okay, so as I am connecting, and the reason I have connected here with my MySQL Workbench, because I first need to retrieve all the data from my database to my this particular script, right? So def fetch data, here what I'll do, I'll simply write a query as select star from products, mean I am retrieving all the data from my products table. Then I'm using my cursor to execute this query. Then I'm fetching all the data and I'm storing them to my data. Then in my column I'm kind of creating a data frame, right? So I'm creating a data frame using pandas and I'm storing them to my df variable and I'm returning my df. Okay, and I'll send this particular data frame to this function of sync with Pinecone. All right, so let's say what's the problem. It's saying embed model is not defined. Embed model, it will be embed model. Okay, so now let's understand what this function does and what this function is. So the function name is sync with Pinecone, and this function will help us to upsert our all the data to our Pinecone vector database, right? So first up we define our batch size set to 100. Over here you could see 100, and this is crucial for performance. So instead of sending one record at a time to Pinecone, which would be incredibly slow for large data set, we group them into batches, and this significantly reduces the number of API calls. Okay, and we then calculate the total batches to help us track the progress. You could see by this, and here, and the calculation would be this length of data will be 129, because in our, if I come to my MySQL Workbench and if I just simply run a query as select count product ID products, okay, and if I run this, it will give me 129. So I have, so my length of my data would be 129. So 129 plus my batch size, so 229 minus 1, 228 divided by batch size 100. So my total batches would be 2, right? All that. Now let's talk about this main loop, right? And we use TQDM here. So for I in TQDM, as I said earlier, that TQDM is a fantastic library that gives us those beautiful progress bar right in our console. Okay, and it makes monitoring long running processes a bit of easy for us. And this loop iterates through our data and extracts a batch of record at a time using pandas ilog.in function, and this ensures we don't pass that end of our data, especially in the last, potentially our those smaller batches. Okay, and inside our each batch we prepared three key components that Pinecone needs. One is our this ID, then our embedding, then our metadata. Okay, so first is our ID. So every vector in Pinecone needs a unique identifier. Here we are simply using the product ID from our data frame to convert into a string. Then we have our text, and this is where the magic happens for semantic search. We are combining multiple textual and categorical fields like product description, name, brand, gender, price, and color into a single comprehensive string for each product. Okay, and the reason and the why, because this combined string will then be converted into a numerical vector or embedding, and that captures the overall meaning of the product. And the richer the input text, the better your embedding will be. Okay, after that we'll be sending that text to my embed model to get our embedding. Okay, and finally we have our metadata, and this is extra information about our product that you want to store alongside its vector in Pinecone. We can use this metadata later for filtering search results, displaying product details, or providing additional context. So think of it as a rich dictionary of attributes of each and every item. Okay, and now the final code block of it, where we use another TQDM progress bar to show the upserting vectors progress for the current batch. And this particular index.upsert function is where the magic happens. We are passing it a zipped combination of our IDs, embeds, and our metadata. Okay, and here this upsert is a key term in our vector databases. It means if a vector with that ID already exist in your Pinecone index, it will be automatically updated with the new embedding and metadata. And if it doesn't exist, it will be inserted as a brand new vector, right? And this makes Upsert incredibly flexible for both the initial loading and keeping our index bit of fresh. So in the Asian, this sync with Pinecone function is extremely important for our uploading data pipeline. Okay, and after that we need to call those two functions of our fetch data and the sync Pinecone, and we will do that using by simply writing a main function. So def main, here first in my data I'll take fetch data, all right, and then I'll simply call my sync with Pinecone and I'll simply pass my pandas data frame, all right, and then at last I'll initialize the main function. So after that I'll initialize my main. Okay, after all these things done, as I've said in the previous file, we need to close our cursor. So our cursor close, and my db connect also close. Okay, I'll save it, and all right, after that I need to run this particular file. So Python, now that we have inserted our vector embedded data to our Pinecone vector database, now we need to design our backend API structure. Okay, so for that I'll first create a backend file over here, under which first let me create a folder as, let's say, db. Okay, and under this db I'll create a file as MySQL.py, and this file I'll write the connector function so that my application gets connect with my MySQL database, right? So it will be an same function that we have used earlier in the Pinecone file. We'll simply import our MySQL.connector, then from .env we'll import load.env, simply load our .env function, all right, then define our get db connection, all right. Now let's describe the function. We'll simply return MySQL connection connect, under which we need to pass our parameters. So one parameter would be our host as localhost, then we need to provide our user, which will be of course root. Generally it's root, but if you have changed at the time of installing your Workbench, you need to change it as per yourself. Okay, then for the password I'll simply fetch it from my environment variable, so os dot get env, okay, where I'll simply pass db password, right. Then at last simple, the database that I wanted to use is Shop Assistant 2, right. I save it. Okay, all right, after that we need to define our services. We need to create our services folder. So let me first create a services folder over here. So services, under which we'll be having two types of services. Okay, one will be our Gemini, chain.py, which will interact with our Gemini LLM, and one will be our vector store. So vector store.py, which will interact with our vector store, which is our Pinecone vector database, right. Now let's come over in this Gemini chain.py, and first again we'll start with import couple of dependencies. So our OS, then as we are using Gemini, so import Google dot Generative AI as GenAI. Then from .env we need to import our load.env, and then from backend dot services dot vector store, I need to import my vector store. Okay, so first let us create our vector store. Okay, so in the vector store, what we'll do, again let us import couple of dependencies first. Import OS, then from .env our import load.env, then from LangChain Google Gen AI we need to import our Google Generative AI embeddings, and then from Pinecone we need to import Pinecone and serverless spec. Then from LangChain Pinecone, where is that? LangChain Pinecone will import Pinecone vector store. Okay, it is saying some error. Import LangChain Pinecone could not be resolved. Alright, we'll check it later. Okay, so now let's load our .env files. Alright, then we first need to get our embedding model. So init our embedding model, right? Here we'll do embedding model. We'll call our Google Generative AI embeddings. We'll pass our model slash embedding 001. Okay, alright, after that we need to add our Pinecone. So init Pinecone. Here we need to initialize our vector store. So pc call our Pinecone. Here I'll simply pass my API key with os.getEnv, my Pinecone API key from my .env file. Okay, then I'll to initialize my index, where I'll simply use pc dot the index what I want, and the index that I want is my Shop Assistant. Let me check if it is right or not. We have declared we have declared Shop Assistant. Okay, so vector store, the spelling is wrong, so vector. Alright, vector store. Right, so Shop Assistant. Now we simply need to add our vector store. So we'll do initialize my vector store with Pinecone vector store, passing our parameter, our index, then the embedding model we are using, so that our embedding model, so embedding would be our embedding model, and some text key we need. This will be text, or you can also main a description for a better understanding. Okay, alright, I save it. So my vector store is done. Now you could see over here I have my vector store. So here first again I need to call my load.env. Then here I need to provide the system message I want to cater my chatbot to perform in a certain way. So my system message would be here. Okay, alright, you are an helpful assistant that helps user find information about the products in a shop, and you can answer questions about product details, availability, and recommendation based on user preference. If you don't know the answer, you should say I don't know, or you can cater it better if you want, as per your wish. Okay, then we'll be having couple of function, right? So we'll be having function of get relevant context, right? Then we'll be having another function of generate gen response. pass. Okay, now I need to create this function. So now for the function get relevant context, here we need to pass some parameter, and the parameter that will pass over here will be our query, because as per the query I'll want my RAG application to find some relevant context out of my vector database, right? So come over here. Now first I want to store my results over here. I'll call my vector store, then I'll use similarity search, where I'll pass my query with the number of similarity chunk I want. As of now I'll want only one chunk. You can test it by using 3, 5 multiple chunks. Okay, then if I received a relevant chunk, then I need to gather the metadata of it. So metadata with results of index of 0 dot metadata, because that's where the metadata is stored. If I got the metadata, I simply need to return all my columns values with that respective metadata. Okay, you could see we have our product name, our product brand, our price, gender, primary color, but for the description we are getting the metadata from this result 0 dot page content. Okay, after that I'll simply return that if I don't receive any kind of relevant chunk, I simply write off that no relevant product found, or no relevant, you can say search found. Okay, this generation response function here will pass our query and our history, so that our chatbot gives us the answer as per our query and as well as our previous conversation, right? Okay, so first thing we need to do, that we need to configure our Gemini API key. So Gemini dot, I'll use my configure. Okay, here I'll pass my API key, which is of course os dot get, sorry, it will be os dot get env. Simply pass Google API key. Right after having configured that, I need to define that which model I'm using. So model GenAI dot, I'll call generative AI model. I'll simply, here I need to provide the name of the model, so it will be Gemini 1.5 Flash. Alright, then I need to get the history, right? So in the history variable, I'll store the history, and rather than I'll just append the history. So you could see in previous, as I am passing the history over here, so I need to first append my history in this history variable. So history dot append, and here I'll have to append the user query. So user query right over here. Then I need to get the context, and to get the context I'll use my get relevant context function, and I'll simply pass my query over here. Okay, alright, and after having the history, after having the context, I need to provide the prompt, and the prompt would be, I first need to get my system message. You could see my system message right over here, system message, then the history I have, then the context I have. So to generate a proper response, I'll be needing my system message to kind of cater my application that how it should give the answer. Second, I need my history, that what kind of conversation I have had in the past. Third, the present context. So that will be my ultimate prompt. Then I need to store the response. So response model dot generate content. So I'll be using my generate content. Okay, here I'll simply pass my prompt and then dot text. Okay, and whatever happened, I again need to append that to my history. So history append, and this time I need to append the response from my assistant. So okay, then I simply need to return my response and my history. After creating our services, we need to create the routes, like we need to export our API routes. So I'll again create a simple routes folder. Here I'll create a file as let's say chat.py. Okay, and another folder just to get all the products, so products.py, right? So in the chat.py, what I'll do here, I need to import from FastAPI the API router. All right, then from Pydantic I'll import my base model so that my um, what do you say, that the request or that and from Pydantic I need to import base model so that my responses across my API should get a proper format. Okay, and of course at last from backend dot services dot my Gemini chain, I'll import my gen response to generate the response via API. So first call my router, initialize my API router, then simply create the base model. So my chat request or base model, here we'll have our query which will be in the format of string, and also we'll be having our history which is indeed a list, which is indeed will be a list or an empty list as per the beginning, and then we'll keep append on that part. Okay, then router dot, for the post method I'll use /chat. Here in this API user can ask any particular query and my application give a particular response for it. Def, let's say my chat, here I provide my request of my chat request, then simply store my response and my history using gen response, where I need to provide my request dot query to get the query and also request dot history to get the history. Okay, after having my response and history, I simply need to return them. So I return them using this response history with history. Okay, some error is saying, okay, there won't be any colon, of course this is the exporting, we are here we are exporting our API route, right? So after exporting our chat route, we need to export our get all product route. So it is also will be easy. So I'll just copy this import from here, I'll paste it over here. I won't be needing my base model, but I'll indeed need some change here. Services backend .db .mysql, I need to import the getDB connection, because to get all the data I need to fetch that data from my MySQL database. Again, initialize my router, simple router is equals to API router, then router dot, and this will be a get method. So simply use /products. All right, then def get products, where I'll simply in my DB variable I'll connect to my database first. So get DB connection, then I'll initialize a cursor to execute the query. So my cursor here db dot cursor dictionary would be true. Okay, after that I need to execute, so my cursor dot execute, and to get all the product I need to use the command of select star from products. Then I need to hold those products into product variable, then cursor dot using this fetch all function, So fetch all, right? So after cursor's work is done, I need to close the cursor. So cursor close, then again close the database connection, and simply return my products. All right. Now we'll test our APIs. So now let get inside my backend folder. So cd backend. Here we need to run our FastAPI backend, and to run it we need to have our main.py file first. So backend main.py. Okay. Now here what we want, we need our from FastAPI. We need our FastAPI. Then from FastAPI dot middlewares dot course import course middleware to kind of reduce any course origin error. Then from backend dot route we need to import our chat route and our products route. Then initialize our fast API with a title, let's say Shop Assistant. Okay, there will be an fast API title, right? There will be a first bracket over here and another one over here. Okay, then we need to add our route. So app dot we need to add route. So we'll use add route. So not add middleware actually first. We need to initialize our middlewares. So here we'll use our course middleware with our allow origin, allow credential, allow method, and allow headers. Okay, and this will just simply helps you to use this API particularly in across any port. Okay, then app dot I need to include my router, and the first router that I'll include will be my chat router. So chat dot router. I don't need any prefix, just simply router. Okay, then again app dot include router. Here products dot router simply. Okay, so now we'll run our application. Okay, so we'll run with uvcorn. Will come under our folder backend dot main app. Right, now let's see what it's saying. Alright, so it's saying that no module named Google Generative AI. Alright, so okay, so we are having these two problem as LangChain Pinecone could not be resolved for this one, and in this file we are having this problem as this Google Generative AI is not could not be resolved, right? Okay, so what we'll do in our project.yml we have Pinecone client. We need to change this Pinecone client to Pinecone, okay, because this Pinecone version have been depreciated in our recent times. Okay, so for that what we'll do, we'll simply uv remove Pinecone client. Okay, all right, now what we'll do, we'll simply uv add Pinecone. Done. All right, clear this thing out, then run it again. uvcorn backend main app. Now Google Generative AI, right? Now for that we'll simply install uv pip install Google Generative AI. Okay, all right, then we'll run it again. uvcorn backend main app. So this problem is gone. This problem is gone now. Okay, now let's wait a bit. Alright, again we're still having an error saying no module name Pinecone. Okay, we'll simply uv pip install langchain Pinecone. This is a problem you might generally face while working with Pinecone. Okay, that recently they have depreciated their version from Pinecone client to Pinecone. So that's why I tried to show you that how to take care of that dependency problem. Okay, now again UVCon backend main app. Oh. All right, we'll wait a bit to see if there is an error or not. 1 2 3. Good. We'll copy this. We'll come to our postman. Here we'll create a new request. So duplicate. Let's say I first want to fetch all my products, right? So here I'll simply write products, send it, and you could see we got all our products from our database. All right, now let's try our post method API. So duplicate. Let me first save it. Okay. Now here I'll write chat. Okay. All right, now here I'll use this particular query as what is the price of the latest Young One Pro shoes, and I need to initialize my history because I'm testing in the FastAPI backend, so I need to provide the history as an empty list. Okay, but while we'll be doing that through our Streamlit, we don't need to provide this kind of empty list. Okay, so send. Okay, it's saying okay, it's would be post method. So send. Here we go. Hi there, the Adidas Young Moon Pro is gray is predicted as 10,999. Histories. So the code we use, that we are using that dot append to kind of add to all my conversation to my history. We have done it over here. User, what is the price, all this thing. Okay, now let's do it one more time. So what is the price of Nike shoes? Let's see what's it's giving to me. The Nike Jumex Vaporfly in green for men is priced at 18,999. All right, so we'll save it. Now we need to create our Streamlit UI. So now for the front-end Streamlit UI part, right? So I'll simply create a front-end folder over here. So a front-end folder where I'll create the file of app.py. All right. So you could see in our py project.toml I have added request and Streamlit. So if you don't know how to add it, simply uv add Streamlit and our request. So requests added, you could see resolve package, we have already added those things, so no issue. All right, so in my app.py, what I'll do first, and the reason we need request is to get those API requests from the backend. Okay, Streamlit as ht, good. Then I need import requests. Okay, first of course set our page configuration as chat with the PDF. No, not chat with the PDF. It would be Shop Assistant, page icons, not books. Okay, I just cut it out. All right. Okay. Now, as you have seen in the demo, that in our sidebar we are creating our chat interface. So first, let me initialize chat history. Okay, so if I do have a chat history, if my chat history not present in ht.mySessionState, then I'll simply initialize the session status. Then I'll simply initialize the chat history, right? Okay, so now let's sidebar chat UI. Okay, so ht.sidebar title chat with our Shop Assistant, and then let us for a markdown sidebar dot markdown ask questions about product prices and more. All right. Okay, now display full chat history, full chat history in sidebar, cause after you ask the first question and then you move on to the second question, you'd like to see the previous question answer, right? So for that we need to showcase every conversation from first to last. So we'll loop through. So for message in ht session state dot my chat history, all right, and then if the message that I'm having it starts with the user, then I'll in my sidebar I'll simply use my markdown of the message. Okay, and else I'll simply show the message which will be of my assistant. Okay, so if the message starts with user, I'll show that, else I'll show which one will be start with the assistant one. Okay, now we need to get user input, and to take it I simply use ht.sidebar dot text input, type your message over here. So I'll save it, and now I'll run this application. So to run this, Streamlit run frontend slash app.py. Okay, all right. So here you could see we have our type your message over here. Okay, now let us complete the next. Now the thing is, for this particular user input, we are not using our Streamlit normal Python. We have to connect this user. We need to send this user input as a query to our backend. So we can't just take our user input like this. So what we'll do, we'll use with ht.sidebar. Here I'll take my user query, where ht.text input, type your message over here. Okay, and here I'll change it a bit as type your message over here. Also I'll use a key as user input, or you can also make it user query, as we are keeping our backend as query, so we'll keep it to query. Okay, then if ht dot button, so if user clicks on the button, written as send. Okay, then if user query dot strip, so if we have a user query, let's see, if we have a user query, what we'll do, we'll simply implement a try except block first. Except exception as e ht.error, and we'll print our error. Okay, now in this try block, what we'll do first, we need to get our response. So in res, we'll use requests dot, and the method to get our response for user query will be our slash post method. So post here, I'll use my http localhost 8000/chat, then simply JSON query the user query. Okay, but we cannot only send our query, right? We also need to send our history. So comma, then history as session state chat history. Okay, now after sending that as our response, we'll take the data res.json. So we'll take the response in our data. Okay, then ht dot session state dot chat history. So session state dot chat history would be my data of history. Then ht dot rerun. Alright, then I'll run the whole application again. Alright, so this is how I'll take the input, and this will help us for our whole sidebar chat application. Now the main page. Okay, so now for the main page, first I'll add the title. So not here, of course, ht dot title shop, not shop assistant, it will be shop product catalog, and let us give a good icon. So Windows semicolon, I'll use this sign, got it. Okay, then ht dot markdown, here I need to get, as we are using HTML, so hr tag with unsafe allow HTML true. Okay, then we need to fetch the product from the backend. All right, and here we need to add those lines of code that will help us to fetch the product from our backend database. So I'll paste the code over here, and here you could see that we are first taking the response from our this particular URL of /product, and we are using .json to extract the real data, and we are storing that in our product. If we don't have the product, we'll show an warning as no product found, and if we do, we'll first get the filter based our values of brands and products. And for those column headers, we'll have this column 1, column 2, column 3 as our brand, gender, and price. Column 1, of course, as I said, brand for all the brand. Column 2, gender for all gender. Sort price with 3 type of sorting price of default, low to high, and high to low. Then we need to apply our filters in all those columns. Then we need to apply our sorting for based on those price from low to high and high to low. Then we need to add some custom CSS with our product card hover, product title, product meta, product description. These are some normal simple custom CSS. Then we need to display our product into 2 column, okay, of columns ht.column with 2, and this is how we will be displaying our products. Okay, so I'll simply save this, And before running our front end, we need to run our backend. So UVcon backend main app, let it run first. Alright, now we'll run the front end. So Streamlit run frontend slash app.py, because we are in this root folder and our app.py is under frontend. Okay, I'll maximize it. You can see our chat interface right over here. See? Okay. Now let's, as per this, let's ask some question. So what is the price of Nike shoes? So I'll paste it over here. Send. Okay, so it's saying that HDR object has no attribute at starts with, so there is an error at line 19. So let's fix it. Line 19 starts with user. Okay, so it's saying message starts with user. So it must be S starts with, right? So I'll save it and I'll refresh it again. Paste the query, send. See, the Nike Zoom X Vaporfly in green are priced at 18,999, which is the same result as per our Postman. Okay, so this is how you can easily chat as per your product catalog. All right, and if you want any kind of updation of feature in this particular application, comment in the section, like comment down, I'll look through that. Okay, so yeah, thanks for watching.